In this session, we're going to look at the instruction set, and then we're going to take a look at some of the addressing modes available for the 6502 processor. So to start off with, we'll look at complex instruction set computers versus reduced instruction set computers, or CISC versus RISC. Then we'll look at the addressing modes, and then get into the specifics. So there's four main addressing modes we're going to look at. There's immediate addressing mode, absolute addressing mode, absolute indexed addressing mode, and indirect indexed addressing mode. And we're going to look at examples using HDL language to get a better idea of how each of these work. So first off, complex instruction set computers, or CISC, characterized as having what we call a rich instruction set. So it loads operands from memory and performs an operation. And once it's finished the operation, it stores the result of that operation to memory. And it does all of this in one instruction. So the advantage of this is that it's one instruction. The disadvantage, perhaps, is that the instruction may take many clock cycles to execute, but requires a smaller number of registers. Now, a classic architecture that we see that uses this complex instruction set is the x86 architecture. And we're going to look in more detail at the x86 architecture a little bit later in this course. It's more of a complex architecture than the 6502, so we'll move into that. RISC computers, on the other hand, smaller number of instructions than a CISC, but it has more registers available. So that reduces the need to access system memory, and this in itself saves time. So these limited instructions perform simpler tasks. A data operation may require two instructions to load the data and another then to perform the operation. And then again, another to store the result back to memory, so multiple instructions. So RISC architectures are designed to execute individual instructions at very high speed. So ARM and RISC-V are examples. And again, we'll talk more about these architectures a little bit later on in the course. For now, we're just sticking to the 6502 because it's much simpler architecture. So let's look at the idea of an instruction set. So what do we mean by an instruction set? So CISC processors support multiple addressing modes. And what this does is it enables efficient access to memory. So let's take a look at how addressing works then, specifically for the 6502. So CISC processors support multiple addressing modes for the 6502, and each processor defines its addressing modes based on memory access patterns that are used by the software that's available at a higher level on that particular architecture. So the four that are available for the 6502 are immediate addressing, absolute indexed, and indirect index. So let's look at an example of what that might look like for each of these. So with immediate addressing, the operand value immediately follows the op code in memory. So this allows us to enter the byte value directly into our code. So these are actual absolute values here. So the value here, 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 and here. So the bytes in this example then are the value of 1 through 4. And we'll be adding the bytes together in reverse order, so from 4 down to 1, in anticipation of using a looping construct a little bit later in this section. But we can see here that the first thing we do, I'm just going to get my pen thing here, is we're going to load into the A register our first value. Then this CLC here means to clear the carry bit. Because we're loading our first value in, we can assume that there's going to be no carry. And then we perform our next three calculations. So we're going to add this value, we're going to add this value, and we're going to add this value. Okay, so the accumulation then will be in our A register, and we can then act accordingly after that. Okay, so that's the immediate addressing. So we have the actual values that we're just adding on top of each other, basically one after the other. So load A, clear C, and then three add operations, which is ADC. ADC means addition. So the pound sign, remember, or the hashtag, and the dollar sign mean that it's an immediate value. So it's immediate hex value, not an address. So the next addressing is absolute addressing mode, and it's also called direct addressing mode. And it specifies that the memory location containing the value to be read or written by the instruction. So rather than the actual value itself, we're pointing out a location where that value is. So a complete instruction then consists of 3 bytes. The first byte is the opcode, then 2 bytes for the address to be read or written. And here's an example here using HDL. And from our previous example, we first store the 4 bytes of data. So you can see here, and I'm just going to get my, let me finish loading this. Reference each address to add them all together. And then a loop would be better, so we'll do that next. But let me just quickly go through what we see here. So here, we're initializing the data in memory. So we're putting this value here into this location in memory. So, okay, we're storing it. And then the same thing here, the same thing here, and the same thing here. So each of these values is stored in a memory location. Okay, so this just refers to somewhere in memory where there's space that we can store this value. Then what we do is we load this first value here, right? So it's extra steps. Then we clear our carry, but again, because it's the first value, of course, there's not going to be any carry coming from previously. And then we add the 3 values on top of that. So we load it into the A register, and then we add the 3 values together. But we're pulling them from an address location rather than loading directly the numerical value itself. So it shows us how we can pull something out of a memory location. Next is absolute indexed addressing mode. And it computes a memory address by adding a base address to a value in the X or Y register. So by decrementing, we move to the next value. So in this example here, you can see that this here is the same. We're just loading everything in memory. But then now we're loading into X the value at 03. Then we're clearing our carry bit because it's the first value. And then we load into X the value here. And then we decrement, which takes us to the next location in memory. We add that value. We move to the next location in memory, add that value until we've added all the values. Okay, so you can see that it's a lot of lines of code, so to speak. But what we're setting up for is the ability to do this as a looping construct. So let's look at that example then in the next slide here. Oops. There we go. So absolute indexed addressing mode. So we can add 4 bytes together, and then we can put in a looping construct. So the same idea here, but we actually put a loop in order to be able to add those 4 bytes together. So the same example with the looping construct. So you could see that in the previous example, all those were repetitive. So we can put them in a looping construct in order to minimize the code needed in order to perform that set of operations. So it may seem like quite a bit of work to set up for 4 numbers, but what about if you have 100 numbers stored in memory, right? Then it starts to make a lot more sense. Rather than having to write out the code for every single one of those numbers, we can just retrieve the first number, decrement to the next storage space where our next number is, add it, decrement to the next, decrement to the next. So you can see how this is a much better way of thinking about how to solve problems anytime we can remove repetitive processes through looping constructs. Of course, it's a good idea, and I'm sure you guys are learning about this in programming as well, how to do looping structures to simplify your code and maximize your efficiency. So with indirect indexed addressing mode, we can use a 2-byte address stored in a memory address range. So somewhere in this range, right, for the 6502 as base addresses. So it adds contents to the Y register to produce memory address used by the instruction. And advantages to this method is we can start at any memory address location that we want to. And this is an example of indirect indexed address mode. So the base address of the byte array is at 0200. And it's first stored at addresses 0010 and 0011, as we can see here. So the code uses indirect indexed addressing in a loop to add the bytes together, which is what we see here in this part of here. So with indirect indexed addressing. Any memory address can be stored at those addresses before the summing code executes. But note that indexed addressing must use the Y register. So you can see here we're using the Y register then rather than the X register, because just the way it works, the X register is not available for use in this particular addressing mode. So you can see there's lots of different ways to store our data, our numbers, to retrieve our numbers, depending on what's best for the situation that we're trying to solve. So that's all I wanted to talk about here. So we looked at complex instruction set computers versus reduced instruction set computing. We looked at addressing modes. And then with the 6502, we looked at 4 different types of addressing: immediate addressing, absolute addressing, absolute indexed addressing, and indirect indexed addressing mode as well. All right, that's it for this session. Thanks for listening.